Now, extrinsic semiconductor, as we know, the semiconductor doped with some suitable impurity atoms, it is called extrinsic semiconductor. So, extrinsic conductor semiconductor are of two types, that is N type or P type. In the doping section, we have seen that if I doped with some impurity atom, the conductivity increases of a semiconductor increases. So if the impurity is added with is if the impurity is done with the trivalent dopants, that means if it is done with the group 13 elements, that is they have 3 valence electrons. For example, indium, boron, aluminium, they are called P type semiconductor, and if they are doped with the group 15 element, that means they have 5 valence electron pentavalent, that is example arsenic, bismuth and phosphorus, they are called N type semiconductor. So N-type semiconductor is obtained by doping the tetravalent semiconductor, silicon or germanium, with some pentavalent impurities such as arsenic, phosphorus or antimony. They are the arsenic, phosphorus and antimony are of the group 15. So it is doped with pentavalent impurities such as arsenic, pentavalent or antimony. So this is the type of the, if it is in such a way, then it is called a N-type semiconductor. So in the figure we see a pentavalent impurity atom substitutes the trivalent, tetravalent silicon atom. So this is phosphorus, it substitutes the tetravalent Si atom. Now we can see that one electron is free here because it is a pentavalent, because its valency is 5. So one electron is free. As each pentavalent impurity donates one extra electron for conduction, it is called a donor type impurity. Now if I increase the temperature, electrons will free from its covalent bond, creating a hole. So here electrons are the majority charge carrier and holes are the minority charge carrier. Here electrons are due to the impurity and due to the temperature. Due to the impurity and the temperature, and holes are due to the temperature only. So that's why electrons are the majority carriers. See, Ne is very greater than NH. Why it is called N-type semiconductor? Because here the current is carried by the negatively charged electron. That's why it is called N-type semiconductor. So if a semiconductor is doped with a trivalent impurities, that is boron, aluminium, gallium. So these are the, if it is doped with these trivalent impurities, then it is called a P-type semiconductor. So here in the figure we can see that aluminium is doped, uses is 3, because aluminium is 3 valence, its 3 valency, so it uses its 3 valence electron in forming the covalent bond with 3 silicon atoms, and one covalent bond is with a neighboring silicon is left incomplete. So an electron from the neighboring silicon covalent bond can slide into the vacant atom, creating a hole there, creating a hole in the bond. Now this hole is now available for conduction. So here the number of holes is very greater than the number of electrons, because here holes are due to the impurity and temperature, and electrons are only due to the temperature. So here holes are the majority charge carriers and electrons are the minority charge carrier. As the current is carried by the positively charged holes, so it is named as p-type semiconductor.